Yeah, so let's see another example for the solution of the initial value problem. But this time the initial values are not given at time t is equal to 0. So we call them as the shifted data problem. Shifted data values. Okay, shifted data values. So let's take the question for the solution. Y double prime plus y is equal to 2 times t, whereas the values are not given at time t is equal to 0. The values are given at times t is equal to pi by 4, and y value is y by 2, and y prime value at pi by 4 is 2 minus under root 2. So in this case, since the values are not given at time t is equal to 0, when we will take the Laplace transform of this equation, so we will not know the values of those at f of 0 and f prime of 0. So in this case, what we can do is we can shift this time by this equation. So we can say that t is equal to t tilde. So this is the symbol we call as tilde, and plus pi by 4. Pi by 4 is this over here. So we will convert this equation in terms of t from t to t tilde. So in this situation, when we convert from t to t tilde, we will also change to represent y from y to y tilde. So therefore y double prime will be y tilde double prime, okay, and y will be y tilde. Okay, so we will represent it like this. So in this case, then we can replace y with the tilde. So y tilde double prime plus y tilde is equal to 2 times t is t tilde plus pi by 4. Okay, and this equation will now follow these initial value problems. So it will be, instead of y, we can say y tilde, and then this will be for 0 conditions. In terms of y tilde, it will be 0. So it will be then pi by 2, and for y prime, y tilde prime 0, it will be also 2 minus under root 2 as before. So now we can take the Laplace transform of this modified equation. So this is the double prime, so it will be s square, and it will be capital Y, and then also we will represent it by tilde minus s, and it will be y tilde for 0, this value, and then it will be y prime tilde for 0, and then it is y prime, but the Laplace of that will be the capital Y prime, and then over here it is t tilde, so its Laplace will be, for t it is 1 over s square, so it will be 2 over s square, and for pi over 4, so it will be pi over 2. Will be pi over 2, so by multiplying by 2, and then since it is a 1, so its Laplace will be divided by s. Okay, so now we will collect the terms of y tilde. So it will be s square plus 1 y tilde over here, and then minus s, this was pi by 2. Okay, this was pi by 2, and then this is y prime of 0, this was 2 minus under root 2, so it will be 2 minus under root 2. So So it is 2 over s square plus pi by 2 s. Now one more step, s square plus 1 y, capital Y tilde, that will be equal to 2 over s square plus pi over 2 s, then it will be plus pi over 2 s, and plus 2 minus under root 2. Okay, so this will be the, and then y tilde will be equal to now 2 over s square plus 1 plus pi over 2 s over s square plus 1, and then pi over 2 into s over s square plus 1, and then 2 minus under root 2 times 1 over s square plus 1. So we have this term. So in this, so this is the expression we found in terms of y, and then we can recognize some of these terms. This one is for this, if you remember, we have done a previous example. Let me show you where we found derived the integral, the Laplace of the integral function. So in this case over here, if you see, the inverse Laplace of this 1 over s square plus s plus omega square was t over omega square minus sine omega t over omega cube. So in this the term which we are getting over here is similar to this, with omega is equal to 1. So we should get the answer for that term should be t minus sine omega t. And for this, with instead of s square, for the s term, we got was 1 over omega square, or 1 minus cosine of omega t. So we can use these results instead of doing it again by the integration of the Laplace method. So we can just write it down over here. So since omega is 1 over here, so this will be 2 into 1 minus sine, omega was 1, sine t, and then t, it should not be t, it should be t tilde, okay, because we are talking about in terms of the t tilde over here. And yeah, this was t over here, so it should be t tilde, okay, for s square. And then for this, it is pi over 2. It was 1 minus cosine of t tilde over here. And now this expression is for the cosine Laplace, so it will be pi over 2 cosine of t tilde, and then this one is 2 minus under root 2, and this is for the sine of t tilde. Okay, so now we can just simplify this expression. Some of the terms will cancel out, so it will be 2 t tilde minus 2 sine t tilde plus pi by 2 minus pi by 2 cosine of t tilde plus pi by 2 cosine of t tilde plus 2 sine of t tilde minus under root 2 sine of t tilde. Okay, so minus 2 sine of t tilde and plus sine of 2 tilde, they are cancelled out. Minus pi by 2 cosine of t tilde plus cosine of 2 pi by 2 cosine of 2 tilde cancelled out. So the terms remaining are 2 t tilde plus pi by 2 and minus under root 2 sine t tilde. Okay, so now we have to move from t tilde to t. Okay, so because t was equal to t tilde plus pi by 4, so t tilde will be equal to t minus pi by 4. So we need to convert it. Remember that this one, when we transformed from S to T tilde domain, so it will be the y prime into T tilde. Okay, and then we can now convert it into yeah, maybe you can say it as y in T tilde domain. So from T tilde now we can convert it into T. So by inputting this value, so y of t will be now equal to 2. T tilde is t minus pi by 4, and then it is plus pi by 2, and then it is minus under root 2 sine t minus pi by 4. Okay, so it will be 2t minus pi by 2 plus pi by 2 and minus under root 2, and then from trigonometry we know the formula of sine alpha minus beta sine a minus b etc. It is equal to sine of t cosine of pi by 4 minus cosine of pi by 4 sine of t. Okay, so pi by 2 cancels with pi by 2, so it is 2t, and then that is under root 2. So sine of t and then cosine of pi by 4, it is, we know that it is 1 over under root 2 minus it will be cosine of t, and then it will be cosine of t sine of pi by 4. So sine of t 1 over under root 2 cosine of t, and then it will be 1 over under root 2. So now you can see that this under root 2, this under root 2, this under root 2, they will cancel out. So what we left is 2t minus sine t plus cosine t. That is the solution. So in this way we can deal with the shifted data problem when the initial values are not provided at 0 time interval. Okay.